Let's do an example. We have these two half reactions that I've taken from a table of standard half cell reduction potentials, and we want to find delta G for the spontaneous electrochemical reaction. So remember, delta G standard is equal to minus NF E standard for the cell. So for a spontaneous process, delta G is negative, so that means that E cell will have to be positive. So for spontaneous process, because if E cell is positive, then we multiply by a negative sign, that will make delta G negative. So we'll have to arrange these half cell reactions so that one is an oxidation, the other reduction, and when we add the two half cell potentials, oxidation plus reduction, we don't want to get an overall standard cell potential as positive. So if we look at these two reactions, they're both written as a reduction. We're going to reverse one of the reactions and write it as an oxidation. So if we reverse the top reaction and make it an oxidation, this will become negative 1.36. And if we add that to 0.52, we get a negative cell potential. So that's not spontaneous. So we would need to reverse the bottom reaction, and if we make that an oxidation, then the cell potential for the oxidation would be the negative of this, negative 0.52. So now when we add 1.36 and negative 0.52, we'll get a positive number. So the spontaneous direction would be to have this as the reduction and the second reaction as the oxidation. So we'll write that. Copper being oxidized, and the chlorine will stay as a reduction. Okay, so now from the table, these half reactions are balanced already, so I don't have to balance them. I just need to add them so that the electrons cancel. And so if I multiply the top reaction by 2, then I'll have 2 electrons on the right, 2 on the left, and when I add them, the electrons will cancel. So when I have my delta G reaction, when I have my delta G equation, N is the number of electrons in the overall balanced redox reaction. So N is going to be 2 electrons because 2 electrons are transferred in the balanced redox reaction after I add the 2 half reactions. So the total number of electrons I'm canceling is 2. So N would be 2 moles of electrons here. That's one thing to keep in mind, how to determine N from the balanced redox reaction. Okay, so I'm ready to plug numbers in for delta G standard. So delta G standard is minus negative N, so it's 2 moles of electrons, times Faraday's constant, times E standard for the cell. And that's going to be 1.36 volts. And then since I've written the copper reaction backwards as an oxidation, I have to change the sign. So it's the oxidation plus the reduction. So this will give me 162 kilojoules for delta G standard. Now remember, let's look at the units. So moles of electrons will cancel, and I'll have units of coulombs times volts. But remember, a volt is defined as being 1 joule of energy for a coulomb of charge. So if I have coulombs times volts, that's equal to a joule. So coulombs times volts is equal to a joule, and so I've converted it to kilojoules for convenience.